All right, this is a Brunsviga Model 11E. So you can't really get your hands on these in the US very easily, but I was lucky enough to have a YouTube viewer give me a really good deal on this. So I'm really excited to be able to do this because this is not something that I had ever imagined I'd be working on. Um, so the only or the biggest concern right now for me is that, it even says AC 230 volts. So I need to open this up, but I'm guessing that because it's specified AC, that it's probably an induction motor instead of a universal, which just means that I'll have to, at this point, it's like I can get a transformer, but I need to just open this thing up and see what I'm going to do. I've always thought it would be really cool to put or replace the motor, maybe not replace the motor, put a battery bank or perhaps replace the motor with one of these so that you could use it off of battery power. And I'm thinking I might do that because if I'll already have to replace the motor, if I don't want to run this through a transformer, then this might provide me with the perfect opportunity to get a little DC motor in there, maybe a little speed control dial, a bunch of vape batteries stacked on top of each other in an incredibly safe way, and be able to use this thing on the fly. It's portable and not wireless, because you see it's got this little roller on it too, so you can like drive it around. Anyway, I need to open this thing up. This thing has a really cool logo. I guess the this thing was called the Iron Brain, which I mean, if you look at it maybe from the side, kind of from this angle, you can kind of see why they called it that. Um, Obviously, the guy who made this name was Brian, and they just spelled his name wrong. All right, I've got this thing partially disassembled here. I've done a couple things already. Removing this was kind of challenging, and I'm going to go over that. But I'm going to try to hit on each of these little components individually and talk about what I'm going to try to do to get this thing running. All right, so here's the little electrical sub-assembly we got, and I got it hooked up to 120 single phase. So this is going to be gutless. This motor's, I mean, I can demonstrate that actually right here. I'll just make these contacts and nope. See, I gotta do something like this because I can't do this with one hand. All right, I think that's gonna work. Yep. So the stall torque on this. I mean, it's basically nothing, and that's kind of unfortunate because I was able to get a tach reading on this, and it was at 3,000 RPM, which is just by doing like some simple little pulley diameter math, it does seem to be what it needs to hit in order for this to rotate at 450 RPM. And I can see the little drums, um, the little shoes contract the brake drum. So I guess I should go over that. So this thing already like instead of having a centrifugal switch governor, which most of these things have, where you have the little brushes and then these little contacts that open when it speeds up, and then it dumps all the current through these little, like a capacitor resistor thing to like shunt it through there until it closes again. But this thing was like, no, I'm just gonna have drum brakes, and then when it gets going too fast, I'll just literally just uses drum brakes, the centrifugal drum brakes. So let me turn it on again. You might be able to see the brake shoes. Um, they expand, and then it does actually limit the RPM, which, so I mean, replacing this motor, I'm not going to feel like that sad about that because this is like this, this is the silliest motor design I've ever seen. Like efficiency wise, I think this thing says 50% ED, which I don't know what that means in German, what that's supposed to stand for, but I mean, I would say it's probably got like less than that. I'm sure this thing's like a 1 to 2% efficiency because it's just a drum brake. I mean, I don't think you can justify that. Anyway, the one thing that does make this a little more complicated for like a replacement is, I mean, obviously all these capacitors that are just, I don't know why there's so many capacitors on here. I really don't know why they needed, I count like at least three and then maybe four, kind of like shunting, or I guess that's probably a bleed resistor, or I have no idea what that little red thing is. But this one's a dual capacitor, as well. So we have like a couple difference in microfarads from the red and white versus red and green or whatever. But it's also got a reversing switch for the motor direction, and that's the this is probably going to have to remain as part of this thing if I do end up replacing this with like a 12 watt, or sorry, what is this, a 15 watt, 3000 RPM little DC motor. And that's actuated by these little arms or feet or whatever on the back of this machine. So plus is raising this arm, minus is raising the other arm. I think clearing just does, yeah, the one on the left. But we have this way for, what is it, plus and minus? Power's off. So I'm going to have to keep this on here. Unfortunately, when I received this thing, it's not fully connected to the base, but this center post with the little rocker is hinging off of, had broken off of this base. And it was like a V-shaped fracture, so I think it probably got like sheared off. I'm not sure how. But I super glued it back on, and it's probably stronger than whatever like horrible thermoplastic nonsense this is. So I'm just gonna wing it. I'm hoping I don't have to like manufacture or 3D print some kind of replacement for this, but it doesn't seem too complicated if I do have to do that. Okay, so something I had to mess with like immediately after I took the panels off this thing was I noticed that these little number wheels on the counter, so like this 3 was completely crushed in, and a lot of these other ones that are crushed, they're all crushed right on the numbers. So that was a telltale sign that we have something very wrong with timing. But what that ended up being was this little thing. So this is the little indexer for the counter. It has one little finger on it right there that just goes positive or negative. But this is attached on the bottom to, there's a rack under this gear, and then on the carriage there's a little rack on the top, so this will spin like or go in the opposite direction to each other. This rack was extremely loose. It was like barely even meshing with that gear. So with that happening, I'll show what this is supposed to do, because that would probably be easier than having it screw up another wheel. But so I have this all in the ones position at the end, and I think these are all, I'll set these all to 0, and I'll do a negative carry. So I'm going to do a subtraction. There we go. So spinning the other way, and there it is. And then we'll do a little ripple carry. Yeah, come on. There we go. So if this was right here instead, it would smush the gear really hard, which had apparently happened a number of times in a number of different spots with this thing. Anyway, I had to take this shaft off, took the bearing out of this side, just in case anyone's having to do this. The timing with this was a little hard to figure out because I just completely screwed it up when I took it out. This tooth right here is horizontal, this one on the thing that goes around. And then these two teeth, so this teeth is like exactly tangent to this like disc. So that was a pretty good way to tell that that was in properly. And then with the carry mechanism little disc things, this one was probably easiest to time off of. This just had to be kind of, there's a tooth on the other side of this one that needs to be on the bottom, like basically the same thing. But after I did that and I got the timing proper, this is basically the only part of this machine that works right now. It's just the counter, which clearing that is pretty fun because it took me a while to get that to work. But go ahead and clear number 2. So that's going to move positive, or whatever, the same direction as an add. You got the little, kind of like a facet thing where we have this little sector thing that spins this around and then goes back the other way. But right now I have to figure this part out, which I'll get to in a second. It's these little input things that these are not pinwheels. These are split step drum, but it made it kind of look like pinwheels, but there's no pins in there. It's fake. But yeah, let me get to that here. All right, so this input is the reason I had to take the carriage off. These ones on the left side, so these are like the fake pinwheels. They don't have anything in them. It's just fake because they're just little selectors for the stepped drums instead right here. So this one does work. So I can go through 1, 2, 3, 4, and then 5 is that silver gear that has 5 teeth, and then 6, 7, 8, 9. And that'll go through properly, but the ones on this side, I haven't really looked at this for why that is yet, but they're just not engaging at all. I think this one like kind of does, but not really. But anyway, to show what that does normally, so if I have a 9 all the way right there, I'm going to hit plus. It's going to start spinning this way. Got to make sure this is in the right spot, but that goes around. We have 9 teeth that are in a row right here that would be going to the transfer gear on the accumulator, and then the end of the cycle it clears. Unfortunately, I couldn't really get to like this at all with the carriage still on there. There's a panel on the bottom that's pretty easy to remove, which I'm just going to pop this up. So this panel down here, or the panel that was here, you can see it's like you can't really do much with that anyway. It does help with getting to like the control section, I guess. With this is the little foot that switches the motor, the main switch right here for the motor. Anyway, I'm gonna try to go over how that got this carriage removed because it was pretty frustrating. I think there might be a better way to do this, and I think I'll probably figure out something when I'm putting it back on, but I'm going to show kind of step by step what I had to do there. Okay, so I removed the number wheel shaft from the carriage, which, I mean, the little gear is held on by this little leaf spring, and then that's like right here. But to remove this, which is right here, there's a little bearing that's screwed in from this direction, but there is a little pin holding in both little collars. I mean, there's this thing on the end, which is where the little tiny gear is, which I didn't want to remove this pin because that looked really hard. We got this pin. It was connected with this, which punched out pretty easily. After I removed that, it was a little more difficult to remove this than I had originally thought, because how this is constructed is we have a rack that is inside of this little slot on the shaft, and there's a little spring right here, and this spring it's held captive by another like wider kind of slot in the shaft. Let me try to push the rack back in to show that. So there we go. So this is going to push against the spring right there, kind of pushing the rack in, and it's held in place on the other side by the pin that goes through the shaft. So I didn't want to take the little spring out. I ended up like spraying a bunch of whatever brake cleaner down in there to get all the nastiness out. And I'm still not sure what the original issue was. With my case, it was basically trying to clear, and then this was, supposed to be holding that in, but this would get to like almost all the way there, and then it would stop, and it was like almost getting there. And I think it was something to do with this shaft, or sorry, the rack in here not moving properly. But I had to remove this. I had to pull the rack out, basically one wheel at a time, because these are kind of held. The wheels are held within their little slot in between the teeth on the rack. So I would get one out, and then I would have to gingerly kind of keep pulling on it. I ended up polishing up the shaft a little bit. I mean, I'm not sure why this was an issue. I think it was just a combination of some rust on the shaft and inside of the little slot where the rack is. So I'm going to try to put this back together. Hopefully I've got that problem fixed. This was the only thing left that was mechanically like wrong with this. I was able to do all four function operations clear the little accumulator wheels back here, but as soon as I tried to clear the what is it? It's like number 3. It's the carriage wheels. I would have that lockup issue. And I mean, ultimately, I'm planning on possibly replacing this motor with this little DC 12 volt motor with another like 5 millimeter shaft like this thing has. But right now, I've got it hooked up to a transformer which is putting out like maybe 190 volts, which is honestly probably why I'm having issues with the most difficult operation, which appears to be the clearing of the accumulator wheels. But I might be able to get this thing working yet. Okay, so I got this thing to work okay, like just barely okay, like it could barely just maybe clear the accumulator wheels without locking up on the old motor, and then the old motor crapped out. Um, I'm pretty sure it's just one of these capacitors. I really didn't bother to check because it was clear at that point that I was just going to have to replace the motor. And this thing's cool. I'll probably disassemble this. I'm kind of interested in what this little uh, brake drum governor thing looks like if I take it apart, and whether there's like an actual way to adjust the speed on it. But this thing is now just a little paperweight. But I was able to get this motor in there, and that was a little easier than I thought it would be. I had a few things just happen to work out pretty well. But I'm going to try to go over what the wiring looked like for doing that, and then the other stuff I've had to do to get this thing to work properly. Okay, so the wiring on this is simpler than it was before because I don't have to worry about capacitors or any of the other stuff, but it's still more complicated than most machines. So this is probably the most complex part, is just the little rocker switch. I didn't have to, these are the original wires still. I was able to keep those all attached here. The wires coming in, I completely disconnected the little, that thing. It's just sitting there. I'm going to probably take it out. Might be able to fit a battery where that space is. But right now I've got positive terminal hooked up, with the battery hooked up to this red one, and then the negative is hooked up to this orange wire. These are both white under here. These are actually the original wires from whatever was there before. The negative is hooked up to the white wire on the rocker switch thing, motor direction switch. The red one, so the orange one is hooked up to that. The red one is hooked up to the contact switch, which is all the way over here. So that white wire is actually the original wire that was soldered onto the back of the switch to begin with, which is like impossible to see from back here. But behind the contact switch, there's, see, the white one going here, and then off the other side of this switch, I ended up soldering the green wire that was originally connected to the rocker switch right here. I just desoldered what was on the switch and took this green wire over to the other terminal on the rocker switch. So all this does is when either plus or minus gets hit, so I think this is plus with this going down. When addition or plus or whatever, this gets pushed down, which makes green with red and white, the little neutral one right here, with black. So that's just going to be what I'd consider like the forward direction on the motor, which goes through the original yellow sheath wired set right here to the motor. And that one's the positive, is purple. And I had yellow or white or purple or whatever, so whatever. And then when it's in subtraction, this one gets positive, this one's negative. So right now this is, honestly, it's a little less cramped in there than it used to be. You don't have to worry about the capacitors. I need to figure out a better way to have these power wires get run through here. Obviously this is, not a good long-term solution, but I noticed that so much of this space back here was taken up by the old motor, and this thing's going to be gone. And I might be able to get a small kind of square lithium battery that I can kind of shove in here where this space is. That would be the dream. If not, I'll have to just have some of it mounts on the outside. But this battery is way overkill. I'm going to put the motor specs in the description, but basically this is an 800 watt or an 80 watt nominally according to Amazon, but it's probably way less than that. I think it says it runs at 4,000 RPM at 12 volts. I think I'm probably getting somewhere around there, but I'll just turn this on real quick. I think this thing is like 480 RPM on the actual like main shaft. When it's at full voltage, it's a little too fast, but here's the thing doing the thing. And it's I got some kinks that I had to work out, and I'll try to go over those as well, but that's what I did for the wiring. Okay, I had a pretty frustrating issue here that took me a while to figure out, and I want to go over that. I had to take this front plate off to get to this. I hadn't done that yet, and that was fine, except for these screws that mount this little plate thing. It just mounts this to the plate. Like, they're really short, and I would have thought these would be the easiest screws to get out in the world, but they were obviously not, and I had just gotten so angry that I had to do this. I mean, I tried to grind down the little whatever post off of this one, and it was not working. Anyway, finally got that off because this thing was giving me a lot of issues. This is the little switch thing that gets pushed when you do any operation. So let me show what this does. This is subtraction. Let me turn it. That's really annoying. Okay. Subtraction. This link right here hinges. It's got the little screw that you can adjust the foot that pushes on the contact right there. Goes through here and gets pushed by this weird contraption thing right here. So there's a little, I guess, roller that pushes on that. So in addition, same thing happens. That thing gets pushed. Subtraction, that thing gets pushed. And I thought it was this bracket right here. I had to put thread locker on that screw because even though I tightened it as hard as I could, as soon as this thing started operating, this would loosen up and then this would start to like bend over. It was pretty bad. Got that done, got this aligned properly. This thing was pretty hard to get in exactly the right spot. But the issue I was having was that every like 10 or so presses of either plus or minus, it would be working fine, and then all of a sudden I press the button and nothing would happen. And I looked down and I would see that this was not like pushing up fully on the contact switch. So I thought it was an issue with this. Turns out it was an issue with this not having enough force, basically. So for this to get pushed down, it's pushed down by this gear moving outwards. So let me show when this gets, you're pushing down a button, the gear, this whole shaft right here moves outward. And this is a pretty weird setup. It's kind of spring loaded inside here. So there's a spring right here going to this gear. And then there's like another sort of, I don't know, like a leaf spring sort of. I don't know if it's supposed to be split like this. But there's also this spring, which I didn't really know why they had done this at first, but this pulley for right here kind of operates like a brake. And when it gets pushed out, or when it's pulled in like this little, I guess they're all leaf springs, but this thing is pushed in, which is pushing the backside of this pulley against the metal. And the backside of this pulley is actually flat, where this has kind of curved inwards. So when it's just like whatever, neutral position, or when you stop an operation, this thing pulls against the metal and it just stops it. I think it's just kind of assisting with the braking. I don't know why else they would do it like that. But I had to put this ring right here. It's like a little, retaining ring that I put underneath this retaining ring, or whatever you call them, the ping things that fly off and you never see them again. because I had to get more tension out of this little flat spring so that this had just enough tension, this spring and this spring combined, to fully push this thing, this little thing with the roller, down far enough to pull this out and engage the little contact switch. So I'm really hoping that's fixed now. This was something that, like, it would happen 1 out of 10 times. And I do something, it would happen 1 out of 20 times. I think it was fixed. And it would happen every single time. And, like, I have no idea why it was happening. I really didn't. But it really looks like it just needed a little extra spring out of this little flat spring that I provided with this little extra retaining ring stuck in here. I think that's, I'm pretty sure this mechanically is basically done at this point. I need to put everything back together before I can, like, demonstrate something like a division. But I'll go over some of the stuff that's a little bit annoying. When I was running this at full 12 volts, I was having some issues. Okay, so with the voltage on this, I have it set right now to, like, full whatever. So just to make sure that that's going to do what I think it's going to do. What do we got? Yeah, it's like 13.28 volts. So at 13 volts, this thing runs almost good enough, but it's running a little too fast. So let's see. Do the plus sign, add. See, that's pretty fast. It's definitely a lot faster than it was going before I replaced the motor. With me, I was getting maybe 420. I believe the correct RPM is 450 on the main shaft, or the whatever operation thing. But I was getting like 400 maybe, and then when I was clearing something like the accumulator, that would literally be like maybe 100 RPM. Like, I would watch it kind of struggle to get all the way down there. But right now, at whatever, 13.52 volts, I'm getting 480 RPM. So that's obviously too fast. I mean, like, I was really hoping that I could get this to work fine. Pretty much everything works fine. There's some little things. One of them is clearing the keyboard via the operation edition, whatever. So let me just run it. So here's it. Oh, wrong button. Which one's add? I can't. The button caps everything. Okay. So it adds just fine. You can see that. Subtraction, whatever. Clearing is fine. Really appreciate how fast this thing took me. I tried so hard to figure out how to make this, because this was the part that made me have to replace the motor really to begin with, was that I could not clear the stupid accumulator. Just didn't have quite enough torque. I would get like 190 volts off my silly little transformer. And this is just, everything I did, it just didn't matter, because I'm pretty sure I could have just taken this thing and, like, poured a bunch of, like, glue on it, and it would have been just fine. But I even went as far as to grind down this cam. So the biggest issue I had, which I'm going to turn this off really quick so I don't do something stupid. The reason this was so hard, torque-wise, was this stupid thing. So this is held in whatever, that position by, you can see, I think, maybe 1 or 2 of them through these holes. But the springs that hold the, whatever, these levers in place that make sure that these stay in the right spot, these levers, every single one of these. So I think we got, what, 1, 2, 3, 4, whatever, that many springs were holding this down. Each one had a little slot, so it was way more spring tension than necessary. I mean, even now, it's like you don't need it to hold that in that hard. That's pretty hard. And it was getting to, like, right here, and then it would just really struggle to push that all the way down. So I literally ground this down. I couldn't get this off to adjust how far that would stick out, but I used a Dremel, and I got this whole cam surface ground down, and that was how I was ultimately able to get it to just barely be able to do this all the way. Come on, stupid thing. Okay. Barely make it. And then the motor died. And now I wish I hadn't done any of that. But anyway, clearing works if you have it on. Yeah. Adding whatever. it's clearing the keyboard. These are these springs are just not fast enough. So I can clear it with the little manual clear. That's fine. If I have it on full voltage and I do a regular addition, it's just too fast. Like this one right here didn't make it. And obviously, if you're trying to add something and it's not clearing all the way, then that's not gonna work. I'm gonna have to reduce the voltage down to maybe, I don't know. I actually haven't really physically figured out what the ideal voltage is for this, but I turned it down a little bit. Let's see how that works. Now it's making it. Let's see what that looks like. That's probably pretty close to what it's supposed to be. That is. Oh, that's only 418 RPM. At least having this thing, I'm able to really fine tune it. I can figure out exactly what 450 is. That's 480 again. See, this is actually 469. That's pretty good. That's pretty funny. What do we got? Nope. Okay. Yeah, I don't know. This is whatever. I mean, honestly, this is I spent so much time figuring out how to make this thing work properly. There were so many things that just I think that with any other calculator, I would have been like, yeah, this is stupid. I'm not fixing this. This is just so frustrating. But this one is so unique to me in the fact that I'm probably never going to see another Brunsviga again to work on one, and that it's so small, and it's just the ideal calculator to put a battery operated little whatever motor on it. So now I have mostly just like the aesthetic stuff to deal with, like figuring out how I'm going to fix these wheels that are just, eh, you know, like that's, I'll figure something out with that. And then little things like, okay, how am I going to make this look pretty? This looks really terrible because I had to use a drum on it. But once this thing is fully whatever gussied up and I've got a better, more portable solution than this going on, I should have a fully portable little Brunsviga Model 11E, which I have yet to see anyone that actually put a portable. I think the Id of Ed did like a replace the motor on a Monroe that was well a lot more complicated than this even. But I'm hoping to be able to have just a fully portable little thing, and then hopefully not even external battery, so it'll just be a fully portable little guy that I can have this giant inconvenient thing to carry around that's incredibly loud, but then people will look at me like I'm insane, and I'll be like, what are you talking about? This is normal people do this stuff all the time. Alright, so this thing is still not like fully 100% adjusted properly, but I can run through a division here on the battery. I've got it set to whatever volts gives me 422 RPM, which is seeming to be pretty effective for not messing up so much. But let me move this over. I'm just going to do pi. So let's see, 355. Clear the. Yep, okay. Divided by 113. And there we go. I'm not sure what. It seems like the faster I run it, the more likely it is. I'll get another shot of this actually. I think it's probably good information. So division is especially taxing on this system because it has to alternate between adding and subtracting pretty fast. So I'm just gonna have it do, what is it? Nothing, basically 0 divided by whatever it is. So it'll immediately underflow. And this is going to subtract, and then as soon as it underflows, it's going to add and then go back to subtraction, basically, at least with the position on this. So let me run a subtraction here. So you can see it goes add, subtract, or subtract, sorry, and then add, and stops and subtract. one of the issues that I had with that was this belt. So after I replaced the motor, this is the original pulley, and as you can see, it's also the original set screw because it just came out so well. I don't have any M4 set screws, and I didn't want to buy one, but I think I've got the pulley that came with the motor somewhere. It's like a 19 millimeter outer diameter, if I can find that. Where did that thing go? What the heck? I think I lost it. Oh, okay, here it is. Yep. This didn't come with the motor, but I bought this pulley because I figured, okay, I'll just buy another motor, buy another pulley. And this is great. It would have been great. But the original motor, as well as this pulley, they somehow figured out, okay, how can I make the most elongated thing here? Like, even when I try to put this on there, which was not going to work because whatever, there we go. That still would have been too short because this pulley is like the shaft barely goes far enough for the set screw to, hold it down, but it goes a good, what is that, half, 3/4 of an inch beyond where it's screwed in. So I had to use the original pulley, couldn't find any that were that size. As a result, even though I had the original pulley and this motor mount thing, which is literally just the original motor mount that I just kind of drilled another hole in and I got in one of those other holes, the pulley was still riding a little bit too close to this switch. So the rocker switch, this one right here on the left, it's hard to see, but the one that, this side right here, that was just close enough to the belt to where the belt would knock it into kind of the neutral position during like a division. So like, you see that I had to grind down that little black tab far enough to where that wouldn't happen anymore, which is about as short as you could possibly make it. I guess I hit it right when I was not supposed to hit it, but now it's just going to go on forever. By the way, this thing, if you ever have to do a division stop, you just do that. Very simple. I'm glad that I figured that one out. But that was something that I had to kind of work out the kinks with that. I had to position this on the base. You can kind of see this thing rides so close to the back end that the other black tab was like, had left a black kind of ground down mark on mine because it had been so close to actually hit it for all the years that whoever was using this. But that's division, or that's, I guess it's subtraction now because I forgot to change the mode over. But anyway, I am going to see if I can get this thing looking good, and then I can finally be done with this. This is the amount of stuff I had to like fully disassemble and grind down and lubricate on this was pretty intense. But there we go. All right, and now for the first time ever, a mechanical calculator that's running while someone's spinning it around on a table. And there's no wires. It's on video. This is the first time. Now, y'all, I know all y'all are seething with jealousy. All right, so this is the best I could do. I really was trying to find a battery that would fit inside the case so that it would not have this obvious, what the heck is this blue thing right here. But this was the smallest 12 volt I could find. Try to get a shot of this in here. So I cut a slot on the bottom so that the case would fit over. This is the little, the battery I bought has this little charger wire connected to it. There's a few wires down here that I ended up running. There's kind of a rat's nest right above this speed controller right here. You can kind of see the bottom. I put like a little foam in between because it's basically just like a PCB with some little leads sticking out the bottom. But this is attached with like a screw or a nut and a washer on the side there, so it kind of helps hold this in place, and it's above the battery in a way that it'll kind of maybe provide a little more cushioning for the battery. If I still had the case off, I would show how dangerous it is to have a battery in here. There's the motor shaft kind of like right here, the back of the shaft. The back of the carry counter mechanism is kind of right here. So that's a big bunch of moving parts right there. But the most dangerous thing, I might have a little video of this, is just there's like a guillotine chopper that chops really fast right above the battery right here. So if this thing was like a quarter-inch higher than this, it would definitely get punctured and it would oxidize rapidly and I'd have my house burned down. But I'm hoping I have mounted this good enough to where that will not be an issue. All right, so using this thing it's interesting. I mean, honestly, it's a little frustrating. I mean, I really hate these pinwheel entry things. I can never really get used to them. I know that's like very common, especially in all the older machines that had pinwheels. But addition is pretty simple. Same as any other machine. This is the little plus or minus add subtract mode down here. But every time you add a number in right here, wherever I want to put that on the decimal, so let's say I want to put that in the ones digit. So right now I have this decimal lined up with this one, which is lined up with this one. So I want to add 25. And maybe I want to subtract 6. And now I want to subtract a number that's larger than that, so 144. Now I have underflowed it, and that is pretty easy to fix with, I guess, any machine, really. I'm going to put it in multiplication mode. This is the complement of the correct negative number. So let's go 99875 and subtract that twice. And the correct answer is negative 125. I can clear the upper dials with this button. It's missing the little 2, but that's register number 2. Clear the accumulator with this, keyboard with this button. You can clear automatically both of these registers at the same time, which is pretty useful. Honestly, I wasn't expecting that with this, considering that it's a mechanical linkage. Anyway, let's see. Multiplication is pretty simple as well. I am currently, let's see. So this is where it sits normally. Just to mention this, there is a little travel lock right here that keeps it from pulling out when it's being transported. But 25 times 25. I'm going to do 1, 2, 3, 5. So that's 25 with this decimal, which matches up with that one and this one. So in this case, I'm going to have to go to the tens position, pull that out. Let's do 1, 2. That's 625. Let's see. Clear that. The counter up here has this interesting little plate that shifts over depending on whether you. This is basically division mode. It's these little red digits on the wheels, which is pretty similar to, like, I guess Facet and a lot of other machines do it like this. But if I have a 1, or let's say I want to subtract first, then it's going to put me in division mode up here, and then I'm just stuck there until I do that. So if you're ever adding a bunch of numbers and you need to subtract something first, don't do that. I guess you add something first. But I guess the coolest thing about this is the weird 3/4 automatic division it does, where it's like it'll do everything automatic division will do except for continue to subtract. Like, you have to keep pressing this button. It's weird. But I'll show how that works. You want to have to start as far to the left or the right as you can. So I'm going to pull that all the way out. Let's do pi, which is, everyone loves pi. 1, 2, 3, 355. Going to add that into the accumulator. Clear the counter up here. Put this in division mode. And then hit subtract. See, the problem is, I don't know if you guys can see what I did wrong, but I forgot this. I'm dividing by 0. So this is what happens when you divide by 0 on a mechanical calculator, by the way. Is this. So whatever. I'm going to reset it. You just do that. Let's do that again. 355. Clear this. Divided by 113. That ought to give me pi, I think. Okay. We got 3.1415. And then there it is. So this thing has this interesting method of doing division where it will move the carriage over by 1, it will correct the underflow, it will do everything that automatic division machines do except for continue to subtract. And I didn't dig into this as much as I probably should have, but every time you do an operation here, it has to bump the little, it has to kick the pulley out. And there's a bunch of stuff that happens in here. I probably got a shot of that earlier. But it seems like they couldn't quite figure out how to subtract, add, and then subtract without you having to physically push this down. And again, I think I'm dividing by 0, but that's okay. I think that about does it for the Brunsviga Model 11E. Uh-oh. There we go. So it's not perfect, but, you know, this is, I'm going to look like the coolest guy in the world by being able to, like, carry this around and just plop it on a table and start doing some nonsense. It's really going to, yeah.